Alright, so today we're going to talk about migration and dispersal. We're going to take a look at the different types of movements that birds undergo. We're going to look in quite a lot of detail at different migration strategies that birds use, and then we're going to look at migratory connectivity and the importance of that to various species of birds, their survivorship, and to even some of the evolutionary implications of that. Your book goes into some other details about all these topics that go beyond the duration of a lecture, and so you'll need to read that, of course, as always. It also goes into some details about things like what triggers migrations and other forms of movement, which we'll talk about a little bit, but it goes into more detail, and also how birds navigate during migrations, those sorts of things. So, in terms of types of movements, we have three major types: migration, dispersal, and local movements. Migration are annual movements back and forth from a breeding ground to an overwintering ground. Typically, when this is probably when you think of avian movements, this is probably what you think of because these are often very significant movements. They're, sometimes extremely long distances. Um, but the distances actually vary quite a bit, as we'll see when we get more into these different migration strategies. They're not always incredibly long. The reason these migrations occur is primarily due to resource availability when we think about our latitudes here in North America, as we experience the seasons, those shifts in seasonality cause this sort of ebb and flow of resource availability. And when resources are scarce, birds that breed here have to move away to find other resources. Dispersal is simply movement from one breeding site to another. There are a number of reasons this might occur, but generally these are very, very short movements, if these movements happen at all. There's actually two types of dispersal. The other type of dispersal happens almost always, and we'll get to looking more at dispersal here in a few minutes. And then local movements. So these are just movements related to daily activity. You're out being a bird every single day. You have to move at least a little bit, and the reasons for that should be readily apparent. You have to eat. You have to maintain your nest, things like that. So the way these movements are studied is primarily with banding data. So banding, for those of you who don't know, is when you put a unique identifier on a bird, when you capture it. There are various ways that you can capture birds. And then later on, if you recapture that bird, you know something about where it started from and various other aspects of that bird, things like the measurements of its wingspan or things like that. So you know some information about that bird and where it came from, and you know where it is now. You know how far it's moved, right? So there's banding, and then there's more sophisticated forms of telemetry. Telemetry nowadays is quite impressive in what it can do, up to having GPS style tags on birds, and you can follow them all over the place as they move around. But that's how we know so much about movements, is through these activities, banding, and these various forms of telemetry. So local movements. Local movements, again, these are just the movements the bird's doing in its daily activity. An example of this would be a bird going to forage. So if you look at an imperial eagle, they can go on foraging bouts that are up to 114 kilometers away from their nesting site for foraging. That is quite the distance. And in fact, sometimes local movements can be even longer than migration distances, which is pretty interesting. So an example of that would be something like the short-tailed shearwater. It will go on these 3-week-long foraging trips that can add up to about 15,000 kilometers, which is longer than many, many, many different other species migrations. So local movements don't necessarily mean short distance movements. And, so sometimes when we talk about local movements, like in the species PowerPoints and the other lectures, these can be significant. These are not necessarily very small movements. What drives local movements? Well, aside from the need to get resources, there are habitat requirements. So species will move within, many species at least, will move within a limited range based on the habitat that is present. Some species won't really leave that particular habitat. So an example, dippers such as the American dipper, their movements tend to be along these lengthy corridors. Well, those corridors are, of course, the streams that they hunt in. So dippers, if you're not familiar, they dive down into the water and they actually, in these fast-moving streams, and they actually walk along the bottom of the stream looking for invertebrates. That's how they feed. They're a really, really amazing group of birds. But because they're limited to these fast-moving streams, their daily movements often look like long, well, they follow the streams, so they're these long, slender corridors of movement. Other resource availability, of course, drives movements, not just food, but any other resources that the bird might need. Water, for example. Predator avoidance is a big thing. You don't want to move if you don't have to, into places that expose you. And so the more you're moving around in any given habitat, the more exposed you get. So you try to minimize that movement. And finally, reproductive opportunities. So obviously, birds will move to obtain reproductive opportunities, and may even limit their movements to obtain reproductive opportunities, which might sound counterintuitive. But if you're really relying on song to attract a mate, and you have a really good perching spot, you might limit your movements so that you don't get too far away from your perching spot, so that you can get back to your perching spot and sing again, and then go eat, and then come back and sing, and then go eat, and then come back and sing. So you might not want to leave that really premium singing spot, right? Because that's how you're going to attract a mate. That's how you're going to defend your mating territory, as we've talked about. At least one of the ways you defend that territory. And so that's a really important aspect of local movements. Now, dispersal is different than local movements because this is moving between breeding locations. Dispersal tends to be very, very short distance if it happens at all. But it's basically moving from I'm going to breed on this territory to I'm going to breed over on that territory is the idea here. And so some examples of things that might trigger a dispersal would be for within a breeding season, if a bird's partner dies, that bird, if it's still usually within the early in the breeding season particularly, that bird may abandon that particular location and find another partner and do another breeding attempt on a different patch of ground, on a different breeding location. It's a form of dispersal. If a nest fails for whatever reason, say a bird leaves the nest to forage, comes back to sit on the eggs, and it returns to a nest that's been predated. A raccoon got into the nest, or something like that. When that occurs, it is possible. It is one possibility, depending on the timing within a season. That individual may abandon that site and move to another site. Typically, these are not sites that are that far away, really, from the first site. Sometimes these little breeding dispersals are only a couple hundred meters, and oftentimes they don't occur at all, even between years, as we'll see when we talk about phylopatry. Sometimes phylopatry is very, very strong, where birds return to the exact same nest. Sometimes between years, birds disperse between nesting sites in a given patch of habitat. So that's another sort of form of dispersal. We'll talk about phylopatry here in a second. Natal dispersal. This is what happens when a young is finally fledged, ready to move on. It's mature enough to become independent. That's why I have a picture of an eastern screech owl here. And this happens with basically all birds. I just am partial to the screech owl because I have a grad student studying it, so that's why I've chose to depict it here. When their young are old enough to be independent, they get pushed out of the territory. The young they have to leave that breeding territory, and there's some really obvious reasons why that's good for the health of screech owls in general, right? You don't want incestuousness to occur, right? You don't want interbreeding to occur because that can cause genetic suppression of a population. And so young disperse away from the parent's breeding territory. This occurs in, I don't want to say all birds because there's no hard and fast. All birds is definitely wrong, actually, but it occurs in the vast majority of birds where young disperse away from the breeding territories of their parents. And screech owl is just one example of that. And these natal dispersals can be maybe a couple kilometers. They can be much shorter than that. It really depends on territory sizes and behaviors. Phylopatry is just the tendency for species to return to the same breeding locations each year, and sometimes this is extremely specific to can be to just a specific nest or nest site, or it can be to a general habitat patch. So it depends a little bit, but it's at least a general region. An extreme example of this is in Arctic terns who do an extremely long distance migration, annual trips that exceed 60,000 miles, but they return to the same breeding site each year, showing very strong phylopatry. Certainly, there are other places they could stop on that 60,000 mile journey that would be adequate breeding location, but they don't. They essentially move from Arctic to Antarctic and back again. And you will see, so here you have two different birds that were tracked, and you can see these movements winding along the ocean, along coasts, and then back to where they came from. This is, up here, this is breeding territory. Down here, this is essentially what I call overwintering territory, basically non-breeding territory, and all the movements in between. This is a tremendous distance to travel to then return back to the same place you started. So that's phylopatry, is what that is. Phylopatry has been studied. There was an interesting study in the 60s that wanted to test just how strong phylopatry was. And so an ornithologist in California it had some white-crowned sparrows breeding in his backyard, and he shipped them in the wintertime to Maryland and Louisiana. And lo and behold, 1 year later, in the next winter, some of those individuals, which had been, I believe, banded, they were somehow uniquely identified, I assume by banding, returned to that ornithologist's backyard. But it's interesting they didn't return to the next winter. And so what this insinuates then is that the guy shipped them off to Maryland, Louisiana. They then went to their breeding grounds in the breeding season from Maryland and Louisiana, which is in the northwest up into Alaska. And then when they were done, they moved back to California so for the winter. So this insinuates that there's probably some amount of genetic even predisposition to where a bird will move to and from. It's pretty interesting stuff. Otherwise, why not? Why wouldn't the bird just fly back to Maryland again, right? Like, well, I came from Maryland, I'll go back where I came from. So they're not just going back where they come from, they're going to a specific place. So this is showing 3 types of migration, or categorizations of migration, and then a simple model of residence. Basically, you have the shaded in area and the non-shaded in area here. That's here. This is where birds are breeding, and this is the non-breeding range of the bird. So this is for a resident species, or a sort of sedentary species that's just stays in the same general area year-round. And then you have 3 types of migration. You have facultative, obligate, and then a third form called nomadism or nomadic migration. And so we're going to look at all 3 of these. Facultative migration is what happens when birds move at varying distances each year depending on conditions that are available to them. And these include things like eruptive migrations that we'll take a look at in a second. The yellow warbler that you see in the picture here is an example of a facultative migrant. If you look at the graph on the right, you'll see that prey density and warbler density in a given area are linearly associated, right? There seems to be a relationship there. What that insinuates is that they will move out of an area in response to lower prey availability, right? Here, where you have low prey availability, you also have low warbler density, and here, where both are high, you have the opposite situation. C is obligate migration. Obligate migration just means these are regular, annual, predictable movements. This is what you think of when you think of migration. The birds that come here in the spring and they leave in the late summer or early fall. And then nomadism is a strategy where birds move wherever resources are essentially available to them. And oftentimes this means that their center of breeding moves with them as well, which is kind of interesting. They're very flexible in terms of where they breed, so long as food is available. There's also something called partial migration, and partial migration is a mixture of these strategies, typically a mixture of facultative and obligate migration, and even residence all together. And so we'll look at that as well. Here we have a facultative form of migration, the eruptive migration. Eruptive migrations tend to be cyclical in a non-annual sort of way. So here we have a common redpoll The common redpolls are typically in the winter fairly far north, but in eruptive years where conditions are very harsh and resource availability is very limited, they will move much further south. Every year I'm on a Facebook page where people post about rare birds in the area, or um, not even necessarily rare birds, but uncommon birds in our area. And every time there's an eruption year, people get very excited about various finches. Sometimes it's snowy owls that you'll see a good movement of snowy owls come into the area. Um, it's just birds moving in response to conditions that are severe, but it's a much more extreme thing, because what happens is it's like a very large number of individuals all kind of moved at once. It's like a big push of that population. And again, it tends to be cyclical. So you can see here with the redpolls that these responses are occurring about every other year. So in one year, you can expect not to see any redpolls or almost no redpolls, and the next year you have a much higher chance of seeing redpolls at feeders. This is all driven by the conditions and resource availability in an area. Here we have an example of partial migrants where we have, these are European blackbirds, and you can see that across different parts of the range, they can be residents, they can be facultative migrants, or they can be obligate migrants. Some of in the northern part of the range, those are obligate migrants for the most part. So this is a partial migrant strategy, where if you look across the whole entire range of the species, you have a variety of strategies at play. We have lots of examples of this in our lecture material from the different bird species. So I think, what's one this week? I think if you look at the hooded pita, it's an example of that, where you have a northern subspecies that that is an obligate migrant, and then in other parts of the range you have resident birds. So it's a partial migrant. A couple other types of migration. One's called loop migration, and actually the Arctic tern that we looked at earlier was an example of loop migration. But you might expect a bird that migrates to move from one space to another space, from its breeding grounds to its wintering grounds, and more or less along the same route. That's very intuitive. But this is not always the case. And instead, sometimes, like in the common cuckoo, you see here a bird that follows one route from the breeding ground to the wintering ground, and a different a different route as the bird leaves the wintering ground and goes back to the breeding ground. And so you create this loop, right? It's like a circular path between the two locations. That's called loop migration. Another form of migration that's pretty interesting is called leapfrog migration. And what happens in leapfrog migration is you have a sort of, if you think of the distribution of the population as it moves north to south, within the mid-latitudes of that distribution, those individuals don't migrate, or they move very, very little. But as you move out from that, different groups at further and further distances in terms of latitude from that mid-latitude point migrate further. They leapfrog over each other. And so that's what you can see here. The fox sparrow. Now I will say this is not the western subspecies of fox sparrow, but that's okay. So here's if this whole range north to south here is our distribution of this species. And the fox sparrows, this is just a western subspecies, but that's okay. Um, Anyways, here would be the middle of that, right? This is the mid latitude of this distribution. This is up 48-ish degrees north. Look at the most extreme end here. Just from the northern point. This is about 60 degrees north. Look at how much further the individuals at the extreme ends move to migrate. So if you're up here, you've got to move a really great distance coming down to Southern California. What about at the intermediate spaces here? Note that they actually move shorter distances. So this population leapfrogs here, this population leapfrogs here, and this one here. You would expect that, maybe this population moves a certain distance. This moves the same distance. This moves the same distance. This moves the same distance, so they don't jump over each other. But that's not what they do. It's called leapfrog migration. We have lots of examples of this. This is attitudinal migration. So attitudinal migration is when species use altitude to move between conditions that are acceptable and resource abundant and that are not. And so an example of this is the resplendent quetzals. The resplendent quetzal during the breeding season breeds in cloud forests. So it's up in the mountains. And as the breeding season ends, it moves down onto the Pacific slope. So more sort of to kind of like the foothills of that region. It's not really foothills, but lower in altitude. Then it moves for some period of time onto the Atlantic slope, basically spending a few months in that particular area, about 3 months, and then it moves back into its breeding territory again, moving between these different altitudes. So right, if you look here, the breeding range is around 1,250 to 1,500 meters. The non-breeding Pacific slope range is 1,300 to 1,450 meters. So not tremendously different, but within a slightly narrower band of altitudes. But then once it moves out onto the Atlantic slope, there's a much, much lower altitude, 700 to 1,200 meters, much, much lower altitude. That's the idea of altitudinal migration. We have a lot of species that we've talked about, where I'd be like, it sort of migrates, it might move up and down a mountain. It describes most species that breed up on mountains, particularly like in South America and the Andes or something like that, where a species might breed up in the mountains and then move down off the mountains outside the breeding season. Austral migration. So there's not really a figure in the book for austral migration. I made this very beautiful figure with the assistance of Google Earth and PowerPoint. So the idea here of austral migration is that, well, first off, you have to think about what happens normally. Which way do birds go when they migrate in after the breeding season? Well, here in North America, they head south. They're done breeding, and then they head south. But in the southern hemisphere, everything should be flipped. If you think about the southern portions of South America, like in Argentina, you think about southern portions of Africa, like in South Africa. You think about Australia, right? They're at latitudes in the southern hemisphere that are not dissimilar from the latitudes here where we're at. Only their seasonality is flipped, right? Their seasonality is like 6 months pivoted from ours. So shouldn't birds there move north after their breeding window? That's the question that one has to ask. And many of these species haven't been studied that well, but there are definitely austral migrations that occur. These are birds that move north in their post-breeding season. I think the book says something like 200 species. I don't recall the exact number, but there are species that do this. They move north afterwards. They move from these higher southern latitudes toward the equator. Just note that one of the things that really restricts the amount at which this happens is simply that there's much less land area in the southern hemisphere than there is in the northern, right? Think about how much space North America, Europe, and Asia take up in the northern hemisphere, and then look at, you have Australia, which is a fairly large land mass. But then, like when you look at South America, and you just have, as you get down into these latitudes between say 30 and 50 degrees or 60 degrees, there's very little land here. There's relatively less land. So that means there's just going to be less species doing this migration, simply by matter of land area for those species to exist. But nonetheless, this is austral migration. So in other words, a bird in Argentina, a migratory species in Argentina, at the end of the breeding season, has to move north to get to better resource abundance and generally better conditions. These birds do have an advantage over the northern birds, and that is that there are overall fewer barriers to these migrations. If you think about, like in the northern hemisphere, you've got things like the Sahara Desert. If you're migrating across northern Africa, that's a heck of a barrier, as we have discussed previously. So there are fewer really, really harsh barriers to dispersal in the southern hemisphere, so that means that overall movements are a bit easier for these species. So nomadic species. This is an example. We talked a little bit about nomadism. So when you talk about nomadic individuals, you think about people that move with food availability, and that's really what this comes down to. Where are resources most available? I'm going to move with those resources. So this is a red-billed qualia. And what you can see in this map is the areas of green are areas where there has been enough rainfall across that year to create the grass seed that this species needs in abundance. And the red dots are little colonies of these species. And you can see in different years that the colonies are spread out in different regions in association with the green, in association with the grass seed. It's as simple as that. These species that are nomadic, oftentimes they're not just moving with food, say, in some given window or something. They just pretty well constantly move to where the food is, and then breeding opportunities are just associated with those abundant resources. So they can breed sort of wherever. It doesn't matter. They just have to have the resource availability. So like in the case of the red-billed quailias, they just have to have that grass seed and, of course, an adequate place to construct a nest. And then they can breed. They don't have to go back to a certain place. Migratory connectivity. So migratory connectivity is talking about how movements occur from region to region, because within a given within a given species of birds, there will often be multiple breeding regions, breeding grounds that can be used. And so, if you have high connectivity, what that means is between a given given year's movements, you see individuals from a single breeding ground going to a single wintering ground. So this might represent, one. This is 3 breeding grounds for one species, but all the individuals in this breeding ground tend to go to this wintering ground, whereas all the ones on this breeding ground go to this wintering ground, etc. If you have low migratory connectivity, it is the opposite, and this is somewhat unintuitive. But what this means is, if you're an individual in this breeding ground, you can go to any of the wintering grounds. You don't have that strong connectivity to this specific wintering ground. It's essentially the idea of, it's like the opposite of philopatry, having very low, a low association with that particular wintering ground, and instead being able to go to any of them. And the alternative is true as well. You might move from any one of these wintering grounds to any one of these breeding grounds. An example of this with common hoopoes is given by your book. This is a species that, at least with these examples, kind of exhibits low connectivity. You have 2 different individuals here. The red dot represents the breeding area. This is a shared breeding area for these 2 species. But these 2 species do not go to the same wintering area. If there was a hike, I said species. These 2 individuals. All right, these are 2 common hoopoes. These 2 individuals. If there's a high connectivity, they would go to the same wintering area. They do not do that. They take very different paths and they go to very different wintering areas. Right? Here you have an individual. Move this out of the way. These are both, it looks like, in Switzerland. That's what it appears to be. Traveling through like France and Spain, going across the Strait of Gibraltar, and then entering up here in, I believe this is Mauritania, in Africa. And then here you have an individual that decided to just shoot from the same breeding location straight across the Mediterranean, which is pretty impressive in and of itself, into sort of eastern Algeria here, and then eventually down into eastern Mali. Now, I was curious about what the distance between this wintering ground and this wintering ground were for these common hoopoes, so I just went into Google Maps and I just measured approximate distance. It's about 850 miles between those 2 points. These are very, very different breeding grounds. Like, this is a huge distance. I mean, it's obviously a huge distance just looking at the map, but just to give you an idea, that's about 850 miles difference. This is clearly, there's not like overlap, all right, on these particular overwintering grounds, not breeding grounds, overwintering grounds. But they both came from the same breeding location. This is an example of low migratory connectivity. Okay, migratory paces and paths. The length and duration of migration varies by species. For most species, they have to rest at various points along the journey, and they use either hop, skip, or jump strategies as part of the migration, or at least that's how they're described. These are sort of just general terms to describe these movements. Hops are maybe what you think of when you think of a migrating bird. Certainly, in my brain, personally, it's what I think of, even though this isn't always how what's done, is essentially short distance movement with a pause, and a short distance movement with a pause. Essentially stopping off over and over and over again, or hopping across the map to the wintering destination. Jumps are no stops, just going all the way from point A to point B non-stop. Um, Hops and jumps have different benefits to them. So hops in the hop system, you get lots of rest. You get the opportunity to refuel yourself, right? But of course, it means your total trip time is much longer. It also means that every time you land in a new territory that you're unfamiliar with, you are exposing yourself to the predators in that particular area. And so there's a cost in terms of potential predation. Jumps are exactly the opposite. If you never stop, you don't have to worry at all about um, that predator exposure problem, right? And you're going to get to your location faster. But you better have the incredibly well adapted physiology to deal with the long migration without stopping. You better have plenty of fat packed on. Um, and in the case of something like a bar-tailed godwit, which is something that does a jump type strategy, uh, there are risks when encountering things like severe weather over the ocean, right? If you encounter a very severe storm over the ocean, you get caught in that. It's not like you can land and take shelter. You're over the ocean, so there's a risk in that respect as well. Uh, and then skips. Skips are in between. Skips are birds that maybe do one or two stops, so they don't hop, but they skip or bound across their migration path, and they sit somewhere in the middle. Um, they sit somewhere between hops and jumps in terms of exposure to predators, rest and resource recovery, and things like that. And so, an example, that's a Hudsonian godwit. That's the godwit on the right. The one in the middle is the bar-tailed godwit. So you've got bar-tailed godwit, Hudsonian godwit, which represent jumps, the one in the middle, and skips, respectively. And then the Swainson's thrush as well. Oh, I think this. I'm sorry. This is the bar-tailed godwit. I'm just like, wait, that's not right. So this is a bar-tailed godwit. This is a jumper. This is a Hudsonian. Okay. Okay. Here we have migration routes. So most birds follow a sort of preset routes that they take. And sometimes these are very well defined routes in migration. Not all birds do this when they migrate. Some birds have a much broad fronted migration where you can't easily define the movement path that's going to be taken. But again, some birds are quite the opposite with well defined paths. And so here you can see the 5 major paths that raptors take globally for migration. And these paths are really, really useful, and our understanding of these paths is very useful for conservation purposes and for estimating population sizes. Because what happens is along these paths that these raptors take, we have all along all these paths ornithologists and volunteers that go out and they do raptor counts during the migration. And so they're literally standing and they're counting like this many Swainson's hawks just flew by, or this many red tails, whatever. And that those counts that we do every year give us an estimation of how the population is doing. And in some of these places, the land draws all these paths together into very narrow areas. Um, and in those places, you can get, I mean, you can see here in Mexico, for example, and the book talks about this, where all these paths converge into a spot where you can count migrating raptors from essentially all over North America as they're headed south. It's really, for one, it's really just cool. You could go to a place and see hundreds and hundreds and hundreds of raptors flying overhead in a day. But it's also very, very, in practical terms, beneficial from a conservation standpoint in monitoring raptor population size. An example in our region, or at least in, I should say, my region, of a observatory for raptor migration is called Hawk Mountain in eastern Pennsylvania. And this is just a place where the mountains, the ridge top is a place where these raptors migrate over top of this ridge top. And you could go out there and count the raptors. And you can go type in Hawk Mountain, Pennsylvania into Google, and you can see their website and see some of the stuff that they're doing out at Hawk Mountain. It's pretty cool. Raptors are not the only birds, of course, that have migration pathways. There are, in general, what are the four major flyways. There are also, for North American birds, just as an example, this one here on the right, where you can see that I am, at least, I don't want to say we are because some of you aren't on the East Coast, but I am sitting in the Atlantic Flyway. West Virginia is in a very interesting position because it's right at the border between the Mississippi and Atlantic Flyway. But these are just general paths that, birds might move along one of these flyways or another depending on where they're moving from. And there are places along these flyways, much like with the raptors, where a lot, because of the landscape, a lot of these birds will get driven. The Allegheny Front Migratory or Migration Observatory here in West Virginia is one of those such places where they, as the birds move and they encounter the Allegheny Front and they move up over the front, there's an observation area there where there's a bird banding station, and I have a couple friends and colleagues that work down there, and I've had the opportunity to go down and do a little banding there myself. It was a really amazing experience. You've just got so many birds moving through there and getting caught in the nets. They will often have to close the nets down because they'll have so many birds to band in a very short period of time that they can't keep up with the demand, which is incredible. That's really incredible. And so obviously they band in the fall when the birds are migrating through in the fall. That's just an example of how the geography, the landscape, can direct birds into certain locations. Birds over the ocean have flyways as well, and the map on the left is depicting some of those flyways, just general regions where these birds tend to move around. So that's the idea of flyways. That's migration. There's a lot more in your chapter. It goes on for quite a while, so make sure you get into the chapter and read that. And if you have any questions, reach out.